Science.
And 1, 2.
Woo! Dance. How? Hey kids, Professor Marbles here. Today we're gonna do another science experiment demonstrating the vacuum of space. How neat is that? To the Kennedy Space Center lab. Away!
Over here, we're going to be talking about the vacuum of space. So space is a vacuum, right? It means there's no air, there's no pressure, there's no gravity, nothing. So we need to be able to recreate those conditions here on Earth. And today, I'm going to be doing that using this vacuum chamber. Now, NASA has these really big vacuum chambers called Space Environment Simulation Facilities, and that's what they use to test and create all of their equipment for their astronauts for when they go up into space. The largest of these and the most powerful in the world is in Sandusky, Ohio. Today, I have these two balloons here. This one's big and full of air, and this one's empty. They're kind of like our lungs, but our lungs don't have knots on the end. It'd be kind of hard to breathe. I'm gonna take these two balloons, I'm gonna put them into the vacuum chamber. Now, when I turn on this pump, I'm gonna be taking all the air out from around those balloons. So let's see how the air inside the balloons is affected by doing that. And let's see how it goes. So let's turn it on. And so those balloons are getting bigger. So when I take the air out from around those balloons, the air inside is like, hey, I want to go too. And there's no pressure acting on the balloon anymore to keep the air to its original shape and size. Those molecules inside the balloon, they're trying to expand and get further away from each other and fill up more of the space that's now available to it inside the chamber. That little balloon that was really empty when we started, it's also getting bigger. It's just not getting as much larger because there isn't as much air inside of it to begin with. When we put the pressure back into the system, it's going to go right back down to its original size. And that's because I didn't do anything to the actual balloons themselves. I only changed the air inside the balloons. Next up, I have some water, and I am going to pour a little bit of this water into the cup, and we're going to put that into our vacuum chamber as well. This water is pretty hot. It doesn't have to be hot to do what we're doing. It just makes it go a little bit faster. So let's see how the water's going to react. I'm going to turn on the vacuum pump once again. When we think about the different states of matter, solid, liquid, gas, we usually only think about temperature differentiating the three, but pressure also plays a really big role in that. So the water is now boiling and it's condensing all around the outside of the chamber. So you can't even see it anymore. It's all covered in water and vapor. Lowering the pressure around the water makes those molecules want to get further away from each other, just like it did inside that balloon. It's a lot easier for it to boil. So now there's another question. Did this water get hotter or colder? It actually got colder because we didn't add any heat to it to get it to boil. We only used the heat and the energy it already had to get it to boil. Because again, all the little molecules, they wanted to get further away from each other. They used any energy they had to do that, and they're gonna get colder. So now we know how air is gonna behave. We know how water is gonna behave. Let's see kind of how our bodies would behave. I have this marshmallow here. He is going to play the role of our astronaut today, our marstronaut, and he is going to go on a spacewalk without his spacesuit. We're gonna put him into the vacuum chamber, and marshmallows, they got a lot of air in them, right? So let's see how this marshmallow is going to behave. We're gonna turn it on just like before, and just like in the balloon, all those little air pockets are gonna get bigger and bigger and bigger inside the marshmallow. But unlike the balloon, the marshmallow can't sustain how big the air is going to get. So the air pockets burst. Now we got that big pop, and all the air is gonna be leaving that marshmallow. Right now, there is no air inside the marshmallow, but it's still able to maintain its shape and its structure because there's no air pressure acting down on it. When I put the pressure back into the system, the whole thing is gonna collapse in on itself. And that's because there's no air, there's no matter inside of it to hold it up, and it's now just a shell of itself, and anything that was inside is gone. Instead of having this nice big fluffy marshmallow, I have this tiny little shrinked one. So you can touch it if you want. It's really gummy and really dense, and if you were to eat it, it feels like stale gum in your mouth, and that's not fun. This isn't explicitly what would happen to our bodies in the vacuum of space. A lot of different things are gonna happen all at once, but the concept's there. Any air inside your body is going to try and find a way out by any means necessary. And that's why our spacesuits are so important, because they maintain the pressure our bodies need to not end up like that squished little marshmallow.
What's gonna happen? Am I gonna blow up?
No, worse. It'll go right to your thighs.
My thighs?
And then you'll blow up.
Yeah. So thank you guys so much.
Thank you. Thanks so much for watching, kids. How incredible was that? Don't forget to like, comment, and subscribe. Remember to always look for the science around you, and I'll see you in the next experiment.